Up in 3.5, example E, as recall, all of your inverse trig derivative rules are up top. Okay, so E, this is going to be y equals tan inverse of cosine x. So I'm going to start with dy dx. So how do we do the derivative of tan inverse of something?
1 over 1 plus it's going to be cosine x squared.
Okay. And I'm going to write it as 1 over 1 plus cosine squared x.
Would it be times negative sine x?
Times the derivative of cosine x, which is indeed negative sine x.
Dy dx equals negative sine x over 1 plus cosine squared x, which isn't that sine squared x? Yes.
No.
What it is?
The Pythagorean identity is sine squared plus cosine squared equals 1.
Yeah.
So it would have to be 1 minus cosine squared to be sine squared. Trust me, I was already reasoning that out in my head before you guys brought it up because I had to figure out if it did or didn't switch. So, and then my answer key backed me up. So, okay. And F. Y equals sine inverse of e to the x. So dy dx, how do we do the derivative of sine inverse of something?
1 over square root of 1 minus e to the x squared.
Okay, e to the x quantity squared.
Times e to the x.
Times the derivative of e to the x, which is e to the x. When we clean this up,
Square root of 1 minus, is it just e to the x squared?
e to the 2x is what that would be best written as. Okay, so e to the x goes on top over the square root, and when it's e to the x quantity squared, a power raised to a power, you multiply those, so x times 2 becomes 2x. So square root of 1 minus e to the 2x. Okay? Okay. Example 3. Example 3. That same old problem that keeps coming back in all shapes and forms during first semester. Find an equation of the tangent line to the graph of the function y equals arctan of x over 2 at the point 2 comma pi over 4. Okay, so do keep in mind the arctan, if you prefer, is tan inverse of x over 2, and they give us a point. What we need to find to start off with is
You need to find the derivative of it.
we need to find the derivative.
Then we'll plug that into the slope.
Right, to then use it to find the slope, yes.
Yeah.
Okay. Derivative of tan inverse of something.
1 over 1 plus x over 2 squared. Time it's going to be negative 2 x. It's just negative.
What is x over 2? What is another way to write x over 2?
1/2 x.
So this is really tan inverse of 1/2 x is what we're trying to do here. So the 1 over the 1 plus x over 2 quantity squared times, what's the derivative of 1/2 x? Just 1/2. Okay, that's always my recommendation there. When you have x over something, think of it as a fraction times x. That's what keeps me sane the best, I think. We've got to clean this up. So it's, well, we don't have to, but it's going to be easier on us if we do. With this in mind, I'm just going to leave this one, because it's already fraction within a fraction. You can take the 1/2 and just put it on top, or we can multiply 1 on the top and 2 on the bottom. Which would you guys prefer? Okay, so if we do this, on top, 1 times 1 is 1. On bottom, this 2 has to distribute, yes? So 2 times 1 is 2 plus. Now, first of all, what is x over 2 quantity squared?
X squared over 4.
Okay, x squared over 4
So it becomes
times 2.
2x squared over 4, just x squared over 2.
You guys can take that leap with me. I'm going to go x squared over 2. Okay? Now, ideally, we shouldn't leave fractions within fractions. I mean, technically, we're just going to be plugging in numbers next, and we could probably make it work. But how do we get this so we don't have fractions within fractions? What do I need to multiply out of here? We need to get rid of.
Would it be like 2 plus x squared over 2?
Well, what do we need to do? What do we need to get rid of?
2.
The denominator of 2. So to get rid of a denominator of 2, you multiply by 2. What you do on the bottom, you do on the top. So I think the easiest way there is just multiply by 2 over 2.
2 over 4.
Uh-huh.
4 plus x squared.
Uh-huh.
Which is really just 1 over 2 plus x squared. No, because that's
Because there'd have to be a factor of 2 with the x squared to cancel out, and there's not. Okay, so that's our derivative. What do we need to find here? The slope, which means I need to find the derivative evaluated at 2 comma pi over 4. So any place you see an x, you put in a 2. Any place you see a y, you put in pi over 4. Okay, we don't have any y here, so you just put in the 2. So this is going to be 2 over 4 plus 2 squared. Does your slope match my slope? So we know we have a slope of 1/4. We have a provided point of 2 comma pi over 4. And we were asked to write the equation of the tangent line. So y equals what?
1/4 tan inverse.
No. We're just trying to do equation of a tangent line.
X would be x minus 2 plus 5.
Yeah. Plain old everyday equation of a tangent line. Okay? Okay. Example 4. They ask us to find the derivative, dy dx, when tan of 4x minus y equals 4x. Okay? A technique we can use here is because there is, okay, so the problem we run into is we have this 4x minus y inside the tangent. Okay? It's going to be really hard to solve for dy dx when we have that in there. So a trick we can use is to take the inverse of both sides. Okay, so what we're going to do is we're going to have tan of 4x minus y on the left. But what we're going to do is we're going to do the tan inverse of that side. Okay, and there's a reason you'll see here in a moment. Now, if we do that on the left, that means, of course, we have to do that on the right. So we're going to take the tan inverse of the right, and on the right is just the 4x. What we're making it possible here for is what's going to happen when you do tan inverse of tangent? They're going to cancel, exactly. Okay, a function and its inverse essentially cancel each other out. So when we do tan inverse of tangent of 4x minus y, the tan inverse and the tan are going to cancel each other out, leaving us with 4x minus y on that side. On the other side, okay, we still have a tan inverse, but it's tan inverse of 4x, which is prettier, shall I say? Okay, not as horrible to work with. So, in this case, can we solve and get y by itself now? Yeah, let's work to get y by itself, and then we can take the derivative from there. So, what? I'm going to subtract 4x to the other side. Or I'll just subtract 4x to the other side. So then I'm going to have negative 4x plus tan inverse of 4x. Of course, I don't want negative y, so we're going to multiply everybody by a negative.
Would I rather do that at the end?
Well, I'm getting ready to differentiate both sides, and I don't want a negative y. So that's why I'd rather do it now. Okay. So now that I have y equals, now I would like to differentiate. So derivative of y is just going to be derivative dy dx. Derivative of 4x, 4. Minus the derivative of tan inverse of 4x. What's the derivative of tan inverse of something?
1 over 1 plus 4x quantity 4x squared.
And?
Yeah, plus 4.
Times 4?
Times 4.
Right? Because the derivative times the derivative, that inside, so derivative of 4x is 4. From here, it's mostly cleanup. That 4 out front I'm going to leave for the moment. We end up with, what, 4 over
1 plus 16x squared.
1 plus 16x squared. Now, this is where it all depends what form they want it in. Okay? This could be an appropriate answer. My answer key goes to the point of having just one combined fraction. So instead of 2 pieces being subtracted, it goes and puts it as one combined fraction. With that in mind, so as it is right now, what is 4 as a fraction? 4 over 1, right? What's going to be my common denominator?
16x squared.
Okay. Common denominator is going to be 1 plus 16x squared, if you will. What has to happen with the first fraction?
Has to be multiplied by 1 plus 16.
Right? To get that common denominator, you're multiplying the denominator by 1 plus 16x squared, and the numerator. So I'm just going to write it as 4 parentheses 1 plus 16x squared. That represents the first fraction. By the way, I'm going to go ahead and put it together as one fraction. Sorry. Okay, so that represents the first fraction. And then minus, what about the second fraction?
4.
It already has that denominator of 1 plus 16x squared, so just minus 4. And then you can clean it up one little bit more, because you can clean up that numerator.
Distribute.
Distribute and clean up like terms. If you distribute, you end up with what? 4 plus
It's just going to be
64x squared, and then you have the minus 4, so the 4's will cancel out, and you end up with 64x squared over 1 plus 16x squared. Okay? So half of calculus is still being able to do the algebra behind it, right? Getting a common denominator even goes before algebra. So. Okay, questions there? Okay, notice as promised, all trig functions will disappear. All trig functions did disappear. Okay. Okay, example 5. Let g be the inverse of the function f of x equals 2 cosine x on the interval from 0 to pi. Find the value of g prime of 1. Notice, let g be the inverse function. So what are they defining right off the bat? G is f inverse, right? So here they want us to find g prime of 1. They basically want us to find f inverse derivative of 1, right? They want the derivative of f inverse of 1 is what they're asking us to find. They're just trying to be nice and use g's. Now, could we use our formula here?
What, the 1 over?
Okay, so we're trying to do g prime of 1. Let's set up our formula. Our formula is what? 1 over, and then it is,
F inverse.
no, f prime first, and then f inverse, which is g. Okay, it's the derivative of f inverse of x is 1 over f prime of f inverse of x. Okay, that's the formula. Now, in order to find this, we need to start with figuring out g of 1, yes?
Yep.
Okay. In order to find g of 1, so in order to find g of 1, keep in mind we need to know f of what equals 1, right? Because since g is the inverse, okay, this is the same thing as saying I need to know f inverse of 1, okay? Since g of 1 is what we need to know, f of something equals 1. Now, what is f? F is 2 cosine x. So I need to know, when does 2 cosine x equal 1? Well, what can we do to solve there? Cosine x, when does cosine x equal 1/2? When does cosine x equal 1/2 according to our unit circle? No?
Cosine x at 1/2 would be the 0.
No.
At 1/2. Or I'm thinking pi over 2. either going to be pi over 3 or pi over 6. I'd have to figure out which one.
I know you guys do it different ways, but there's a chart I know. And so at that point,
It would be cosine equals 1/2 at pi over 3.
Okay. Have a way that you know to get there. Okay. Whatever that might be for you. Now, officially they gave us an interval. From 0 to pi, is it ever going to equal pi over 3 again? No. Or is it ever going to equal 1/2? Sorry. No. Because when you go into quadrant 2, cosine is negative over there, right? If we start thinking, so down here there'd be a positive 1/2, but up here it's a negative 1/2. So that's the only one that works there. So what do we know? If f of pi over 3 equals 1, then f inverse of 1, or g of 1, is equal to pi over 3, correct? Okay, so that's your working backwards piece. So go over to my formula I'm trying to fill in. 1 over f prime of, what is g of 1? Pi over 3. Now we're at 1 over f prime of 3. Or excuse me, f prime of pi over 3.
Find the derivative of that and then plug in pi over 3.
Yep. So f prime of x, what's the derivative of 2 cosine x?
Isn't it like negative? Is that like 2 sine 2x or something? Or just
So
negative sine.
when there's a constant out front, I just basically carry that constant down. So derivative of 2 cosine something is going to be 2, and what's the derivative of cosine?
Negative sine x.
Negative sine x. So derivative of 2 cosine x is negative 2 sine x. Okay, that constant just carries down. Don't do anything fancy with it. So we need to know that what that is evaluated at pi over 3. So negative 2 times sine of pi over 3.
It's just going to be negative square root of 3.
I believe so. And so
Or it could be
I have that as my final answer. Could you rationalize if necessary?
what would it become? It become like negative square root of 3 over 3 square root of 3.
Just 3. Because you would,
Square root times square root.
yeah, officially you'd multiply by square root of 3 over square root of 3, which would be square root of 3 on top, square root of 3 over, those cancel. So negative square root of 3 over 3. Okay? Okay, one more. Notice it has a calculator. It's one of those that the decimals, round to 3 decimal places. So, find the slope-intercept form of the tangent line. So it's a tangent line again. They're just giving me a specific form at the point pi over 4, comma negative 1 to the graph of x squared plus x tangent inverse y equals y minus 1, and round to 3 decimal places. Okay, so Larry gave me a point. What do we have to start off doing?
Just add 1 across.
Well, we're not going to be able to make it y equals because there's also a tan inverse of a y. So we're going to have to use implicit differentiation. Okay? Which isn't, I mean, it's tan inverse of just a y. Okay? So that's not going to be a horrible thing there. So, implicit differentiation. Take the derivative of each term. What's the derivative of x squared?
2x.
2x. Plus, what do you notice is happening next?
X times
Okay. X times tan inverse y.
It just becomes tan inverse because it's just 1 times 2.
Okay. We've got to do a product rule, yes. Okay. So when we talk product rule here, the derivative of x is 1. Keep the tan inverse. Well, it's tan inverse of y. That y is the inside of the tan inverse. So derivative of x is 1. Keep the tan inverse. Plus, now we're going to keep the x. What's the derivative of tan inverse of y?
1 over plus x squared.
Except it's not x squared, it's y squared. Because y is what's inside of tangent inverse. So 1 over 1 plus y squared. Now, since that inside is a y, so times the derivative of y, and what's the derivative of y? dy dx.
X squared with 2 or
No,
no?
it's just a y on the inside. That y squared is the formula. You're just looking at what was originally in there, which was a y.
Equals dy dx.
Derivative of y is dy dx. Minus 1, the derivative of minus 1 is nothing. Okay. Dy dx terms on the same side. So I think I will leave my 2x and my tan inverse y on the left. On the right, I'm going to have a dy dx, and I'm going to subtract. Now, this was x times this fraction, yes? What can I do with this x?
Put it in the numerator.
Put it in the numerator. So I'm going to say minus the term x over 1 plus y squared dy dx. And then here we can factor out the dy dx.
This is dy dx equals 2x plus tan inverse of y over 1 minus x over 1 plus y squared.
Mm-hmm. So I factored out my dy dx on top, or on the one side. And then so 2x plus tan inverse y divided by 1 minus x over 1 plus y squared.
You use calculator, right?
Well, yeah.
I'm just making sure we didn't have to go any farther.
No, because what's the next thing we need to do?
I mean, we can get out that denominator, but I didn't know we were going to do that.
No. But generally speaking, we found dy dx. The next thing we need to do is evaluate it at that lovely value. So we're going to evaluate dy dx at pi over 4, comma, negative 1. So x has become pi over 4s, y has become negative 1s. Plug in carefully on your calculator. A decimal to 3 places is what they told us. So
I confidently just put 2x in this. Great start. .29.
Mm-hmm.
I forgot square was right on my good time. And not square.
Give me a square.
Square my like that's a 0.
So. Now officially, once you get your slope, what did they ask us to do? Slope-intercept form of the tangent line. So I'm going to start with y equals 1.293 times x minus pi over 4 and minus 1. And this is where the calculator comes into play again. I got the 1.293x. I know that much.
Calculator again, huh? We're trying to.
It specifically said slope-intercept form. So we can't just leave it in that altered point slope form. But for me, I'm going to be doing, okay, what is that, 1.293 times pi over 4. Except it's going to be negative there.
Well, you didn't plug in your other numbers. Because you got to plug in x and y to find b, don't you?
No. I just, okay. I put it in our form y equals m times x minus x1 plus y1. And then I was just going to adjust this. So as in this is 1.293x minus whatever 1.293 times pi over 4 is, and then a minus 1. My b value is going to come from there. I've taught it.
But I've never done it before.
Okay, but it's an option as opposed to having to set up a whole different equation to find b. Or find b your way. Either or. Okay. Julito, did you guys didn't like how I finished that problem? Or at least a little bit.
I don't remember, but
I mean, yes, could you do the y equals mx plus b, put in your slope, your x, your y? Yes, you can. That's just not how I generally do this anymore. Not at this level, I don't. Did it not work out the same?
value is -1. X value is pi over 4.
Mm-hmm.
So it'd be 1.29. It'd be -1 equals 1.29 pi over 4 plus b.
Uh-huh.
So you just divide across.
Not divide, you're going to subtract. Because you're going to end up with -1 minus whatever that mess is. Okay.